Hi guys, it's Brooke and Haley with Intelligent Concrete, and we had the pleasure of going out to the United States Air Force Academy to do some ASTM C39 compression brakes at their facilities. We are planning on working with the cadets and showing them how to do these brakes, but unfortunately, due to COVID, we were unable to meet with them in person. So we went ahead and did the testing, recorded it, and we're going to teach you exactly what we did today. So first thing is ripping and stripping the samples. After the samples have cured, you're going to take your stripper, which is that long device there, go ahead and wedge it in between the sample and the plastic mold, and then you'll use a mallet to hit it down the side, breaking open that mold so that you can flip it over and release your sample. It is important that you position the mold carefully so that it doesn't damage the sample. It is very important to take note of the angle when you position the stripper so that it does not dig into the side of the sample or damage it there. So what we're showing is how that sample was hit with the stripper and broke a piece off, which could have an effect on the actual PSI at the end. So after that, after you get the samples out, you're going to want to make sure to label them all correctly so you can keep them all straight and it will easily correspond to your data sheets. Per the ASTM, you cover the samples to keep moist until they're ready to break.
And then here you can kind of see what the impact of the nanosilica is on the concrete. As you can see on the right, the reference sample has a lot of pores, a lot of permeability. It's really segregated. And on the left, it's still not the best finish or surface because it was a really high water cement ratio mix, but you can definitely see the impact in all three samples.
Using a set of calipers, you will take the diameter measurements and record to the nearest 0.01 inch. You'll find the average by taking the two diameter measurements, adding them together, and then dividing them by 2. And here we're just showing an overhead view of taking those measurements. So 3.01 is recorded on your data sheet, and then again the opposite side is recorded. Now we'll wipe down the caps and the pads as well as the top and bottom of your sample. Insert the sample into the ring with finish side up. Place the top cap on top of the sample and ensure that the bottom bearing block as well as the machine is clean and free of any debris. Ensure equipment is centered. Place the sample into the machine and center sample within the caps as well as in the center of the machine. Tilt the upper bearing block or movable head so that it is parallel with the top of the cap. And now we'll hear from the Air Force Academy lab manager on how to work their compression machine.
All right here we put the 6 inches because the measurement, that's where the length is. And the diameter is 3 inches, and it varies. You have to use calipers to know exactly the diameter. And then you have your specimen ID, whatever you're going to call it, so you keep it straight. And when we print it out, it will have reference 3. It'll print all this out. And then from here, you always have to hit check procedure, and then turn it on, and then hit run test.
Once it starts, the load is applied at a constant rate until the point of failure. Release the machine by retracting the bottom bearing and take your sample out. Remove the sample and take off the top and bottom rings. Identify what type of fracture it is and record the corresponding break.
Thanks so much for watching. Don't forget to like and subscribe. Ding that bell for notifications. Go concrete, beat asphalt.